Let's come to question number 11. This question is supposed to test your understanding of the difference between a correlation coefficient and a regression coefficient, which is to say between R and beta. Now, before I get into the question, there's something that needs to be noted here. There's a small typo in the question. The question is supposed to be a correlation coefficient of 0.2 between savings and income implies that, not investment, because as you can see, the options that follow are about a relationship between savings and income. Let's say you have a regression model which says yi, the dependent variable, as a function of the independent variable x. So yi being beta 1 plus beta 2 xi plus epsilon I, where epsilon I is the error term. Now, the question says that the correlation coefficient between savings and income is 0.2. So in this particular case, let's consider y, the independent variable, to be, well, alright, let's consider y to be savings and let's consider x to be income. Alright, fine. So the idea here then is the coefficient beta that comes out from an OLS regression would be summation xi yi by summation xi square, where the small xi is the deviation of the xi's from their mean. Now, so this is the OLS regression coefficient, and R square, which is the square of the correlation coefficient, is summation of xi yi whole square upon summation xi square summation yi square. Now, the catch here is that from these two equations you can infer the relationship between the correlation coefficient and the regression coefficient, which is that R is equal to beta 2 hat into under root of x summation xi square upon summation yi square. Essentially, what that tells you is that the correlation coefficient is the regression coefficients times the ratio of the standard deviations of x and y. Now, given that the correlation coefficient is 0.2, all that tells you is that there's a roughly linear relationship between x and s and y. What that means is that if you plot all the data points that you have, and let's consider, well, you're plotting savings versus income, then you have a bunch of points. All that this tells you is that this would be like this, all these points would lie on an approximately on a straight line. Now, the larger this correlation coefficient is going to be a number between 0 and 1. The closer it's to 0, the less linear the relationship between these points. And for a correlation coefficient of 1, if the correlation coefficient is actually 1, then that means they perfectly follow a straight line. Now, a correlation coefficient of 0.2 simply means that they are more or less on a straight line. And however, what you can say is that without knowing the variances of x and y, you have absolutely no way of knowing what beta is, and therefore absolutely no way of knowing how much savings would change if investment were changed, if income were changed by 1 unit. So options 1, 2 and 3 in the question, which talk about how savings changes as a response to a unit change in income. Well, you can say nothing about savings as a response to a unit change in income simply because you don't know what the beta is. You only know what R is. Whereas, well, you can say that approximately these points lie on a straight line.